So now it is my great pleasure to introduce Michael Liik, the CEO of Cymat Technologies Limited. Mr. Liik is the CEO and is also a founder of Cymat. He has a successful record of leading both early stage and high growth Canadian public companies with a unique background that combines considerable operational leadership experience with extensive merchant banking skills. Mr. Liik is also managing partner of Fraser McKenzie Merchant Capital. Mr. Liik is a Master of Business Administration from 1984 and a professional engineer with both designations obtained from the University of Toronto. He's also the president and owner of Liik Fam Holdings, Inc., an investment/venture capital company. And so at this point, Michael, I'd like to invite you on to start the main focus of our presentation here and tell us some more about the recent developments with Cymat.
Okay, I'm on. Thank you, Jordan and Danny. That's a hard act to follow. I was worried there for a second when I was introduced by Neil that I was going to go first and nobody would have any wine while you were going to listen to this presentation. But fortunately, Jordan saved the day. We are, if you can go to the next slide, please, Jordan. Yeah, I don't think we need to go through the forward-looking statement. As I said, I'm Michael Liik. I'm the CEO of Cymat Technologies. We're an advanced materials company, and our focus is on a material called stabilized aluminum foam, which is effectively a very light metallic, a cellular metallic material that has a myriad of applications. We've organized ourselves commercially along three sectors, business sectors. The first one and our most advanced one is architecture and design, and we market that under the Alusion brand. Secondly, we focus on the engineering properties of our material as it pertains to automotive, military, and various industrial applications. And that's under the SmartMetal brand. And then finally, what's our latest business vertical is composite panels, and possibly the brightest future for this material. We operate out of two facilities. Our main facility is in Mississauga, and it's just outside the airport. So we're in a particularly strategic hub, transportation hub, which is important to us because we send our materials all around the world. It's a 26,000 square foot facility. We can generate about $50 million worth of revenue out of the current configuration. And with relatively modest investment, we can significantly increase revenue out of that facility. The other facility, which is just being completed, is in Spain, just north of Madrid. And that's with our partner Alucoil, and that's for the production of these very unique brazed sandwich panels. Next slide. So a little bit about the material. The way we produce this material is we start with a molten bath of alloyed aluminum that's infused with ceramic particles. And we blow gases through it, and what happens is the bubbles form inside the bath of aluminum. They float to the top, and then we skim them off either in a continuous casting process or discretely into casts. The interesting thing about this material is that if you've ever seen it before, it looks essentially like an aluminum aero bar. I've got picture here. I don't know if you can see it. It has a lot of paradoxes in terms of its characteristics. It's very light, and we can produce it in virtually any density from 2% aluminum by weight up to now over 40%. Dimensionally, we have a continuous casting process, so we can make it as thick as 5 inches and 4 to 5 feet wide, and as long as 16-foot panels. Probably the most important aspect of this material is its energy absorption capability. So if you can imagine, if you have a solid material like this, and you're in a collision or some sort of impact, when you hit it, you have instantaneous deceleration. When you have a material like this that's a cellular material, what happens is when you, at the beginning of the event, this material starts to crush very predictably until it gets to about 30% of its volume, and then it acts like a solid. So the effect of that is that you have a controlled deceleration, and that's very interesting to the automotive industry. The other thing is for blast mitigation, what happens, what most people don't know about blast is that what precedes an explosion is a compressed air wave. And compressed air will go through any solid material like butter, in effect. But when it hits a material like ours that's principally air, what happens is that compressed air gets into the cells that are filled with air. You get turbulence, it starts to shred apart the material, and it in effect abates the energy or mitigates that energy. It's temperature and strain rate sensitive or insensitive. It should be insensitive, sorry about that. And that's particularly important because strain rate insensitivity means that it doesn't matter at what speed the event takes place, it's going to perform exactly the same. It's of course non-combustible because it's metal, and completely recyclable, which is particularly important in the industries that we commercialize our material in. As I said, we can produce this in a flat cast form or cast it into discrete molds. The process is highly scalable, and we've managed to drive lots of costs out of the process over the years. Next slide, please. So Alusion, as I said, Alusion is our most developed product line. It's used principally for exterior cladding and interior wall features. It's used in bars. It's a particularly cool looking material. It's relevant today because young designers are generally moving towards more aesthetic or more contemporary aesthetics when it comes to buildings and what have you, and they're constantly on the lookout for new materials that have an organic as opposed to a structured look. So we play a big part in that. The material also is particularly light, so it's easy to work with, inexpensive to install. It's got an R factor because it's mostly air. It's, as I said before, it's 100% recyclable, and we can finish it pretty much any way a customer wants. We've done as crazy things as gold specced finishes in the Middle East in a mall, to powder coating, to all sorts of things. And I can say with certainty today that it has become a globally recognized brand. We've got marquee installations all around the world, from the Prada Museum in Milan, which is a major installation for us, the 9/11 Museum in New York, where we've clad the foundations in the library underground, Vancouver Convention Center, countless office buildings in Manhattan and throughout Europe. So we are a recognized brand, and we are building on that success. Next slide. Well, we deploy a particularly low-cost sales and distribution model. We only have 4 people dedicated to Alusion in the company, 2 directly in sales, 1 in specifications and costing, and another in logistics. So it's a particularly low-cost model. We rely almost exclusively on agents and distributors around the world. Last count, we have over 25 of these agents and distributors that span North and South America, UK, Europe, Korea, Middle East. A recent addition is China for us. They became a distributor last year, a large stocking distributor, and they're doing particularly well for us. And we are always on the lookout for new agents, culling existing agents, and we found that this model works particularly effectively for us. Next slide. We also keep our costs down by using principally digital media for exposure. We used to spend considerable amounts on Architectural Digest and Azure, local design magazines and the like, but we've moved print almost exclusively away from that into digital media. This is the landing page of Arc Daily, which is by far the most dominant of these new digital magazines that the next generation of designers are turning to. Next slide, please. So Arc Daily, I won't get into the details here, and this isn't an advertisement for Arc Daily by any stretch, but we just can't get enough of these guys. They've done a lot for us for exposure. It's very inexpensive. Most years we get 1 million visits a year on this particular site, and it's particularly effective for us. We're also in social media, very active in social media, and this is all the future of design. Nothing's print anymore. Next slide. So in terms of what's been happening on the business side of Alusion, we started to feel the effects of the coronavirus already last December, so almost a year ago, and particularly into January. And that was principally because our larger planned installations were Korea and Beijing. And they, as we now know, entered into COVID lockdowns and slowdowns much before the rest of the world. We've been pretty lucky because when we went into lockdown in March and April, they started to open up their economies. And in Korea, particularly, projects that were delayed took off. In China, anything that's shovel ready, they put a real push on to get going. So as a consequence, we're seeing some solid numbers again in the Alusion division. In fact, we're expecting this to be a record year for Alusion. And not only that, we have a very strong pipeline going into the next fiscal year in the order of $5 million already. And those are identified projects where we're spec'd into it. And generally, we build on that from our distribution and our agency base. So we're seeing the growth that we have anticipated in this division for some time. We're now seeing that as a reality. And this is particularly important for us because Alusion is what funds the company, pays the bills, and pays for the R&D and the development work we do in the SmartMetal aspects of our material. Particularly interesting is Alusion Plus, which we're launching this year, and that came out of the development work we did for our panel business. It's an entirely proprietary alloy that we developed, and it's particularly interesting in Alusion because it's very strong, so it's much stiffer than the alloy that we use now. And it's much more corrosion resistant than the A359 alloy that we've been using for a long time now. So we're really looking for big things from Alusion Plus. It's going to be launched later this year. Next slide. So SmartMetal is our engineering material. The verticals that we concentrate on are automotive, military, non-lethal bullets, and nuclear. Next slide. Starting with automotive, we've had a sort of long history with automotive. We're into it now in a more meaningful way. But the industry itself, as it pertains to our material, has two somewhat competing requirements. Lightweighting has been spoken about for years and years, probably for the last 20 years in the industry. But with the onslaught of the electric vehicle market, or the introduction of or proliferation of electric vehicles, lightweighting is absolutely paramount. The other thing that is paramount to the car industry is occupant protection and improving the crashworthiness of cars. And there's a contradiction here because generally speaking, to improve the crashworthiness of cars is you need mass. And the paradox of our material, of course, is that we can accomplish both. We can take weight out of the vehicles and at the same time improve the crashworthiness of the vehicle. Next slide. So we organize ourselves into three essential component classes or areas in automotive where our material can play a part. The first is crash mitigation components. This is the most evolved of our, call it, product line, from crash boxes that we developed together with Valeo and George Fisher back in the early 2010s, 09s, 10s, to what we're working on right now with Tesseract. Then the next category is essentially putting our foam into body structures or extrusions, what have you. And that's accomplishes two things. First being you're stiffening up the body structure with very little weight penalty. And of course, at the same time, you're getting crumple zones and having the ability to take inner crash energy away. The last thing that we're focusing on, and this is a relatively new family of applications for us, is very high density aluminum foam cores. So traditionally, we've only been able to, with our technology, to get up to around 15 or 16% density by weight. In the last little while, we've overcome that, and we can get to over 40% and even approaching 50% by density. Now, the significance of that is that when you get into that dense foams, it starts to have the characteristics of a solid, yet it's only 40 to 50% of the weight of solid. So if you think about all of the solid cast aluminum components in a car, and they're almost countless, there's an opportunity to look at each of those and the possibility of substituting those with high density foam cast cores. And in some cases, the industry is looking at casting over these to improve the performance aspects of the cores. But by and large, we think that just the density alone will do the trick. We, generally speaking, after the financial collapse in sort of 08, 09, we took the position that we being a small company, couldn't really be in the business of designing parts and what the industry was looking for, which is solutions. So we took the position that we were going to be a material supplier, expert in our material, and let others work with the material. We found that the way that the industry has moved is that that's no longer effective. So we've come to the conclusion that we have to partner with designers and integrators that are familiar with our material, can design with it, and offer these solutions to the industry. The other thing that's happened in the industry is that the OEMs have pushed so much development down to the parts industry and essentially just kept the powertrain and brand marketing and obviously final assembly, and not even in all cases final assembly of the vehicle. So our emphasis now is not to the OEMs, but to the parts industry. Next slide. In terms of highlights, the last 4 years, we've been working on a component called the UDU, and I'll speak about that a little bit later more extensively, but it's essentially being driven by a change in the industry requirements for not only having head-on crash testing or having to pass that crash testing, but also what's called offset crash testing. It's been delayed. It was originally supposed to come on in 2020. With the Trump administration, the industry was able to push the requirements for this testing out, but it looks like it's now coming into effect next year. OEMs are looking for stopgap solutions for this, particularly if they're in the middle of a platform life. Typically, auto platforms these days run 6-7 years. And if you're, say, 2-3 years into that platform life, you're looking for a stopgap measure to be able to pass this new requirement. So we've developed together with Tesseract a device that is very effective for this, and it's been marketed to several OEMs, and we've gotten traction so far with 2 OEMs, and are hoping to have a development program with a major North American OEM shortly. The other area that we're focusing on, as I said, was the putting of or the placement of SAF into the frame of the car. We've been working with a tier 1 and a tier 2 part supplier down in Mexico for a number of years now, and we've evolved to the point where we have quoted on a serial production part, and we're going into negotiations with them on that. Hopefully we're keeping our fingers crossed that that will come to fruition, because that would be our first serial production part in a car. I talked before about the high density castings, a whole new family of applications. And we are in the process of hiring new business development people specifically to exploit that. We think that's going to be an enormous area of growth for us. And the utility of our material there, I think, is going to be very significant. Finally, we announced some time ago, I think a month ago or so, that we entered into a formal cooperation agreement with Tesseract Structural Innovations, and they are the developers of the UDU. And if you can go to the next slide, please, Jordan. They've developed something called the Uniform Deceleration Unit, and this is a very clever sort of piston type device that uses foam and extrusions in a very unique way to absorb the energy of offset crash. So the problem with offset crash is that if you hit a vehicle head on, you can use the frame of the vehicle and various crumple zones that are designed into it to take that energy. And that's a fairly established sort of technology and art, and everybody, all the OEMs know how to do that. If you take the most stringent of the offset tests, which is the one that the insurance industry is pushing for, you only take 15%, or essentially just where the headlights of the car are, and you smash a car at 40 miles an hour into a pillar. The problem with that particular collision is that you can't use any of the frame. So if you can imagine, that's where the wheels are, and the frame of the car is inside of the wheels. So there's no frame, or really no substantial structure that you can use to take away the energy. So they've created this piston that can take upwards of 50% of that crash energy away, and then use the rest of the car, aspects of the car, to take the balance of the energy. It also has the benefit of keeping protruding components around the wheel well, like the suspension components, the wheel, from protruding into the passenger compartment. They, this year, with that particular device, they won the Society of Automotive Engineers Innovations Award, and with that comes the ability to market to all members of that society. And so our timing is excellent with respect to Tesseract, because they're just on the road now, talking to the various OEMs and part suppliers in the Society of Engineers, promoting both their UDU and their partnership with us. From our side, we also have found that having Tesseract with design capability and expertise in working with our material helps us in marketing. I mean, we're talking to a major producer, raw materials producer in the industry right now, with the potential of a three-way partnership with them to market our collective products. So it's already starting to pay some dividends for us. Next slide. This is lifted from their presentation. So as you can see on the right, the diagram, it sits in the wheel well, the front wheel well of the car, and it's a piston. It's very sort of flexible in that they can change the design very quickly for whether it's a small sedan, larger sedan, even into light trucks. And it has the notoriety of absorbing more energy per unit of weight of any solution in the industry. So that device costs about just over $100 US per side. It weighs about 35 pounds. The other solutions that have been proposed, which are steel tubes, they're an order of magnitude more weight than this particular device and aren't nearly as effective in taking away energy. Go to the next slide, please. This is a more detailed look at how it works. As you can see, it's round extrusions. These are all aluminum extrusions that are ultimately filled with foam and then foam all around it. And then it's put together a series of these in a piston-like format, and it's unbelievable how much energy this particular contraption can mitigate. Next slide. Military. So interestingly, the military has a lot of the same needs as the automotive industry. They're looking for lightweighting, maneuverability, and most importantly for us, making it the vehicles safer for the occupants. Where we play a role, principal role, is underbelly protection for vehicles. So what happens is we've developed numerous kits where there's foam that's essentially fit all through the bottom of the vehicle, and then there's a blast plate on top of it. What happens is when a vehicle drives over an IED, improvised explosive device, what happens is there's a massive blast wave that precedes all the shrapnel from these explosions, and that's really what kills, because that blast wave will go through all the steel and all the armor until it gets to the soldiers. And because there's hollow cavities in people, what the blast wave does is it eviscerates all your hollow cavities. That's why you see when a tank goes over an IED, all it happens typically, it jumps up or tips over, but mostly the soldiers are dead inside, and that's because of the blast wave. So our material is ideal for taking away that energy. It reduces it by an order of magnitude, and our material is particularly well suited to low-slung, high-mobility vehicles where weight is an issue, and you don't want to elevate the vehicle too much to accommodate what's called a V-hull that is traditionally used to do that. We also play in the multi-threat component system space. We're hoping to have some development to announce this year in that space as well. Next slide. We have relationships in North America, direct relationships with all the major vehicle suppliers like General Dynamics, BAE, and SAIC. You may recall we had a major program with SAIC where we had a bake-off with BAE, or SAIC had a bake-off with BAE to replace the amphibious vehicle for the Marines. It was a massive opportunity for us. We got to almost to the finish line, and unfortunately, SAIC's vehicle did not get picked. It was BAE, but that's unfortunately the nature of the military business. There's a lot of these sorts of sourcing and design bake-offs. So we maintain great relationships with all of them. We have programs at various stages of development with them, and hope to see some progress in the near future. Our most advanced relationship is with Stells, which we used to call STK. That's an Asian OEM based in Singapore. They produce the Bronco, which is used by all of the major militaries around the world. We've worked years and years to perfect a underbelly kit for them for the retrofit of the Bronco. We are reasonably confident that this year it finally will get its first award, and that's with the Singaporean military. It's not a huge award. It's likely to be only 100 kits, but it's somewhere around $15,000 a kit of our foam value, that is, per kit. And we are expecting that order in early 2021. That would be our first serial production order. The family of vehicles presents about a $50 million opportunity for us. And their strategy is to first launch with the Singapore military and then market off the field test results of their experience and then go next to the UK, to France, to the US. I think even Canada has versions or derivatives of the Bronco. So we are certainly looking forward to that, and it's been a long time coming. Next slide. Non-lethal bullets, very quickly, you're probably aware of rubber bullets, which is the principal non-lethal bullet that's used today. For the golfers in the crowd, the problem with rubber bullets is they're shot out of relatively short-barreled, low caliber or small caliber weapons. So what happens is, because the rubber bullets are so light, when they're essentially exploded out, there's spin that's put on the bullets, and when it comes out of the shaft, the end of the shaft, you either get a slice or a severe slice or a severe hook. It's very rare that you get a direct line with these bullets. So that makes them particularly ineffective, and there's a lot of collateral damage that comes from the use of rubber bullets. Not to mention that when it's very cold out, rubber becomes almost lethal, and when it's very warm out, it becomes mush. So we have developed, together with Nobel Sport, a new type of non-lethal bullet that uses a very, very low density foam core. It's been years in the development. We've shipped almost 40,000 cores to them that in turn have been shipped to the French military for certification. They are now certified by the French military for active use. We've been waiting for our first commercial order for now, I think, 8 months or so. But this being the French, I guess it doesn't surprise me. But we are expecting our first commercial order imminently from them. They are starting to market it to other militaries, particularly the old French colonies. Next slide. Nuclear is something that we have spent quite a bit of time with, particularly in France. We had our material certified in France 5-6 years ago for use in the nuclear industry. We had a couple of installations, and the installations were principally mattresses that sat at the bottom of elevator shafts that took spent rods out of nuclear reactors and transported them down into subterranean storage. And the idea was that we are the final fail-safe, that if that elevator ever failed and went careening down the shaft, it would land on a 6 or 7 foot thick bed of foam and would progressively slow down. So that has come back to life. We've established a relationship with a company called Nuvia, which is one of the largest nuclear contractors in France. They are marketing it under their own brand. We have 5 or 6 quotes outstanding. We're starting to deliver on the early quotes, and we are expecting that business to pick up significantly this year. Next slide. As I said, our most exciting venture going forward, I believe, is our venture on these new brazed panels. A little bit of history here. We partnered with Alucoil, which is a Spanish company, one of the majors in this space. I think it's coming up to 5 years ago now. And they had this concept that the traditional panel, which is essentially just 2 aluminum sheets that are glued together with a substrate of either aluminum honeycomb or plastic foams. That's a very ubiquitous panel that's used globally for construction, anywhere from building cladding systems to elevator cabs. Virtually everything in cruise ships is made of this stuff. So it's a very ubiquitous material, probably a $4 to $5 billion market yearly for it. You may recall some time ago, the Grenfell fire in London was particularly catastrophic. That was clad with these types of panels. And what happened there is that the fire actually accelerated because the panels delaminated because they were glued together. Glue is particularly ineffective at high temperatures. So that, as I said, that actually accelerated the fire and created the catastrophe. So Alucoil had this idea that if you took their panels and put aluminum foam in as a substrate instead, and if you could actually weld it together, so it would be one metallic component, not only would you get a particularly strong panel, but you get the highest fire rating in the market because there's no glues. If you combine that with the fact that building codes are being changed now, principally because of that event, I think we're well placed with this product. We've had to do a lot to make this work. We developed a proprietary new alloy that's much more friendly to brazing. We worked with Alcan extensively with that. And we also had to develop brazing technology, proprietary technology, and that was done with the help of our new CTO, who's based in Hungary, and also with Dana Corp and NRC. We are in a position where the plant has been built. It's a commercial scale plant. If you go to the next slide, what has happened is we were in a position back in March, pre-COVID, to do final trials on this particular product. We're ready to go on our end, but delays have ensued because of COVID, and Spain, as you probably know, has been hit particularly hard. Alucoil's business has been particularly hard hit. So we've been now coming up to 9 months delayed on those final trials. We are trying to get those trials done early in the new year. We've gotten validation or verification from them that they should be in a position to do it then. In the interim, we're doing our own trials in Hungary, where our CTO is based. And for belt and suspenders, we're also doing trials here in the Toronto area with NRC and Dana. We're expecting commercial ramp up after those hopefully successful trials. And initially, we're going to provide the substrate panels from our facility here in Toronto while they ramp up. And then ultimately, we'll have a foaming front end to that plant. And in the interim, once the trials are complete, Alucoil is going to move to get product certifications and customer trials. All that to say that we hope to be ramped up commercially sort of late 2021 with product coming out for sale. Unfortunately, we are somewhat delayed, but it is principally COVID related, these delays. A little bit about the business model. It's a particularly low cost and low risk way for Cymat to get into this market. It is a market of Goliaths. There's only 4 or 5 very major players in this. The way we're mitigating that risk is that the joint venture we have with Alucoil only produces the basic product. All of its output gets sold to Alucoil, who then finishes it and distributes it through their global network. Next slide. We have a very lean management team. Aside from our new CTO, everybody's been with us at least 10 years. Norbert, I'd like to highlight because he is, I would say, the father of foaming. He has 2 PhDs, one particular specifically related to foaming, and he has been a godsend for us in terms of helping us improve our process, consistency of our process, reliability of our process, these new alloys, and now with the brazing. So he's been a great find for us. For the next slide, we have a small board, myself, John Gill, who has a background in private equity and extensive operational background, and lots of capital markets background as well. And Martin Mazza, who is our automotive guy, so to speak. He has 30 years experience in automotive in a directly related field, which is plastic foams, and has been great counsel to the company over the years. And with that, I'll finish my presentation and open the floor to questions. I'm not sure how this quite works, but I'll hand that over to you, Jordan.
Perfect. Thank you so much, Michael. Yes, we are moving now on to the Q&A portion of the webinar. So feel free to go to the menu bar there of the webinar, and there's the Q&A section, and you can type some questions in there. We do have a couple here already for you. So if you're ready, Michael, we'll do it.
Yeah.
All right. So first of all, there's a number of initiatives here as a part of Cymat's business. Which one do you think has the potential for the greatest upside for Cymat?
I think it's a toss-up. I would say that the panel business for sure has enormous upside because we're going to have first mover advantage with that product. And as I said, it's a $4 to $5 billion market. Ultimately, I think all of those panels that go into construction particularly are going to have to be that sort of integrated material with no adhesives. And we don't know of any other way to do that today. So I think that's an enormous opportunity for us. Automotive has always been also a significant opportunity. We just have to crack it. That's all. And I think we are at an inflection point now with automotive. We have tailwinds for sure.
Gotcha. Another one I have here is, to what extent do you use or will you use scandium in the aluminum process?
We don't use it currently. I'm not a metallurgist by training, so I'm not sure what scandium does as I believe it's an alloying material, but it's not relevant to foaming for sure. So I don't know is the honest answer.
Fair enough. Are you going to be able to finance these initiatives without diluting the equity at the moment?
Yeah, I mean, we maintain a very low burn rate. We always have, always conscious of that. And the initiatives that we have underway, we partner largely. So the capital requirements haven't been big. I think when automotive does crack for us and we need new facilities, obviously, we are going to have to raise some capital for that, but there's many ways to finance new growth, plant growth for high volume automotive production. I don't see that as being a problem, but I don't see the need for financing in the foreseeable future. Our Alusion business is strong right now. It's a great margin business, and it's covering all of our costs and R&D expenditures.
Gotcha. I know that nuclear is a bit of a new one here. So I have a question just about nuclear. Can you tell us some more about exactly how you're looking to kind of expand in that direction?
Yeah, I mean, we play a very niche role in nuclear. And as I said, we had some success in France, particularly about 5 years ago in nuclear, and it's a very niche application. It's essentially taking energy away from potentially catastrophic incidents. So now we've taken a much more organized approach to the market. France, just by way of background, is a nuclear leader in the world. There's 58 nuclear reactors in France, and the new ITAR technology is being actually initiated in France. So if you're going to be in the nuclear business, that's where you want to be. We found that the better way to market our product in a company our size is through somebody who is active in that space. Nuvia is a major contractor. They've certified our product. We white labeled it with them. And we think that we're going to see some fairly significant growth in the nuclear business without putting a lot more sort of sales effort into it. So I think we're well positioned there.
Gotcha. Just going back, what was the reason for the military choosing BAE over the version that had Cymat technology in it?
Oh, you're testing my memory now. We're going back, I think, 3 or 4 years. I believe it's that BAE had a lighter, more maneuverable vehicle overall.
So it was designed by the other company to be just kind of a more effective military response
Yeah, like
vehicle?
they were two completely different designs, SAIC's design and BAE's design. And for whatever reason, they found the BAE design to have more utility for the Marines. Now, we're not out of it yet. We're in touch with BAE. The next iteration of those vehicles, it's about 1,000 vehicle ultimate sort of request from the Marines. The first 60 vehicles were done with no add-ons, so underbelly protection or lightweighting initiatives. We're in contact with BAE, and we think we have a reasonably good chance to get onto their vehicle with an underbelly kit and some lightweighting initiatives. They're also particularly interested in our high density foam, and that's a new initiative that we have with them.
Awesome. All right. Well, Michael, we are coming up on 5 o'clock here, so I think we're going to call it for the Q&A today. Thank you so much for joining us and taking the time to be here to tell us some more about the latest developments that Cymat has been experiencing over the last several months.
Thank you.